So first, I would like to present you Jenny, Don, Mike, and Stefan. And personally, I am Maxime. The E is silent. Like, you know Danone, the yogurt company. In France, you have an E at the end. But in the US, they decided to drop it because they say, everybody in the US will have pronounced this Danone. And they don't want that. And for my last name, I have nothing to do with Bugatti. If you see a Hyundai rental car in the parking lot, that's mine. Some logistics. The white paper related to this working group will be released this week and maybe today. And another logistic will be concerning the voting. You are going to vote. We are going to ask you to do some work today, and you are going to vote for the top 10 requirements. That will be at the end of the session. So I will encourage you to download the app if you didn't do it yet. So this morning, I was on the panel, and there is the Major General Sarah that I was listening. It was very interesting what she was saying, and very in line with that working group. And I would like also to go over something that is happening to all of us. In our company, you can have a new requirements coming from above, if you will. And we have our leaders that are coming to us and explain those new requirements. And we are listening to the requirements, and our job is to find a solution. So we go out there, we interrogate the vendors, we do our due diligence, and at the end, so the vendors can propose a cloud solution or hardware, software, tools, so all of this. And the conclusion is we need at least 2 vendors. So we go with 2 vendors. And we start working, we start developing that new solution. And we discover that, well, the integration between those 2 vendors is not that great. And this is where ONUG would like to propose an open approach to have a federated orchestration, to provide a federated orchestration for software-defined infrastructure. So during the presentation, we are going to go over the landscape of today, an architectural framework, use cases, top 10 requirements, and the last piece, you are going to vote. So first, let's go over the present-day landscape. Yes. So the present-day landscape is divided in 3 parts: the application layer, the control layer, and the interface layer. The interface layer is physical and virtual. The meat of the white paper is the control layer. Oh, sorry, I forgot to tell you. You can add photos, no problem. All the diagrams that you will see are also in the white paper. So it could be better than a photo. So I was on the control layer. So today the control layers is different components that are configuring the interface layer. And sometimes it can be an orchestrator, a controller, a tool. It just depends. And also we have the other challenge that the communication between the control layer and infrastructure layer, but also between the control layer and the application layer, could be proprietary or could be an open standard. So it depends. Now I am going to give the microphone to Stefan to speak about the architectural framework.
Okay, thank you. So you see what we have been thinking about in this work group is really how should the future look like. We know these type of changes will take time, especially on the bottom layer with the physical infrastructure. But we also know that the applications today is like the main thing that needs to be optimized in many ways. And what we are thinking, what really needs to happen is that these applications, basically the input on the application's performance goes to these orchestrators. And we still believe that for the foreseeable future, there will be two orchestrators, one for the WAN, one for the data center, simply because the data center infrastructure, you have much more control over how your network looks like, while the WAN orchestrator has to deal with much more with service providers and different hardware standards and so on. These orchestrators then talk to the controllers that basically then talk to the underlying hardware components. And we basically think that today, when you saw today's slide, the controller talking to the hardware, each vendor knows best how to talk to the hardware. What's important really is the standardization of the interfaces from this upper orchestration layer to the controller layer, that we get to one standard, and also that the applications can talk to the orchestrator in one standard. Okay.
Now we're going to jump. Oh, sorry. And now we're going to jump on the use cases, and Jenny is going to speak about number 1 and number 4.
Thanks, Maxime. So the use case 1 is about the application resiliency to support the automatic failover for an application from one data center to another. So for example, when the application fails at the primary data center, SDN orchestration supports to redirect that traffic to another available application without any end-to-end traffic disruption. So use case 4 is that the SDN orchestration provides seamless integration with brownfield network and SDN fabric. In other words, SDN orchestration enables the network to migrate their application dependency map from brownfield to SDN fabric with the traffic steering by programmable interfaces such as CLI web interfaces. So we have a demo for the use cases for later this session. Thanks.
Thank you. And now it is...
To 2 and 3, right? Okay. Number 2, the use case is provisioning application or workload across the data center or the WAN. So you might think, how do you provision an application on the data center or the WAN? And really this is about making the underlying network application aware. So this means classifying at the edge. It's really kind of the next step of not just having maybe 3 levels of QoS. It's actually having a policy per application or policies for the applications you run on your network. So you can identify the app and put it on a path that is giving an SLA for that application, end to end, across the WAN or within the data center. So we're seeing examples of this in the SD-WAN space where you're identifying an app and putting it on a tunnel. You're seeing it in the data center space with VXLAN and overlay where you're identifying an application and putting it on a connectivity path. But this again is the provisioning of an application onto the network where you can do application performance routing, again, based on performance thresholds with primary and failover, as well as workload distribution. So if you have more than one path, more than one data center, you can actually steer and get the best usage out of the underlying network, be it data center or WAN.
Thank you. In case number 3, that's an application that we want to distribute between multiple data centers, and we envision to have the orchestrator to configure everything. And when I say everything, is the virtual environment, the networking environment, the compute environment, the storage too, and even the bandwidth necessary between both data centers. And here we will have 3 potential scenarios. One, we will have the compute in one data center and the storage in another one. The second scenario will be we have all the component for that application in one data center, but also in another one for resiliency. And the third scenario will be we have the application between 2 data centers, for example, in the Americas, and we do a copy and paste to 2 data centers in Asia. So now the main question, can we achieve those use cases? How can we get to the future state? And at the end, what do you want? And this is where we are going to ask you to vote, just after the demos. Or if you want to vote now, you can. You just take your iPhone, Android, and vote. Oops. Here you go. So I click on this.
Okay, good afternoon, everyone.
SDN Federation is a key use case.
So I'm Don Clark, I'm Director of
software-defined
Business Development for NEC.
In this demonstration,
and we'll talk about really the use case example of the brownfield demonstration. First, I have to hand it to Maxine for putting this working group together and leading it so diligently. So can I do that? Okay. So the demonstration that we're going to show, is there a pause? Is really building on that federation model where we're going to use an orchestration system to be able to provision multiple SDN controllers, and in turn the SDN controllers are going to show how the fabric can be controlled from the orchestration. So really this idea of being able to manage multiple data centers with a common policy across those.
Sorry, we have a video issues here. Can you get the I cannot stop this guy.
Okay, well, we're going back.
We have technical difficulties.
This is why we need orchestration.
So make it big. Can you do that?
No, I can't. It's not playing. Okay. Okay.
The open network users
So go ahead and play. And really what we want to show is really a consistent policy even as we move across those different use cases. So. And so ultimately we want to coordinate all of the components in the stack that we're demonstrating here. What we're going to show is be able to provision that networking stack through this demonstration. The NEC controller provides really a variety of different features. What we're going to show today is how we can easily provision this service, how we can visualize all the flows in the network, and then use this network virtualization construct to provide a consistent policy across the network. And this is built on open networking, so it's going to be a multi-vendor environment that we're going to be demonstrating here.
So thanks, Don. So the real demo starts here. So the use case to demonstrate today is to show how to configure and provision data center network using data center orchestrator to migrate the application dependency map from brownfield to SDN fabric. So NEC's data center lets you set the service chaining policies with the network of services using programmable interfaces such as GUI, CLI, REST APIs. So that configuration is going to be pushed to the SDN controller at each data center. And then that SDN controller is going to manage the switch fabric along with the brownfield devices. So the screen you are looking at right now is orchestrator GUI. So top part, green part, is the one SDN fabric managed by data center one SDN controller. And then gray part is managed by another SDN fabric managed by data center SDN controller. So I'm going to use the data center 2 for this demo. I'm going to add the firewall devices at the data center 2 network fabric, and then show the application dependency map there with the virtual nodes. So next screen is going to show real SDN controllers on the orchestrator. So that I have 2 data centers, so you can see the 2 SDN controllers there. So I'm going to use the data center 2 network. So the virtual network for the data center 2 orchestrator shows layer 2, layer 3 network there. So the same way, data center S2 SDN controller is going to show the same virtual network with the existing traffic. So from here, traffic flows from one host at the one subnet to the other host at the other subnet. So and it's this SDN solution handles the layer 2 layer traffic at the same switch fabric. So from here, this is the before the firewall devices is added. So I'm going to show how to add firewall devices from our orchestra, and then that. So now I am creating the egress port of the firewall and egress port of the firewall as a virtual node after connecting to the switch. So the mapping method here is port mapping. So now I am defining the redirection point where to add that redirection policy. So I'm adding the redirection rules on the ingress port of firewall and egress of the firewall by drag and drop from this GUI. So now all the setting is done on the orchestrator. Then SDN controller is going to get that all the configuration automatically. So you're going to see the same policy setting with the newly added firewall ports. And then incoming traffic is going to be redirected to the ingress port of the firewall, and then coming out to get to the coming out from the egress port of the firewall, and then get to the destination host. So when you have multiple brownfield devices in your network, you can use the REST APIs to automate the whole service chaining policies. So you could have the Ansible platform to write all the REST API calls for your service policies.
So if you'd like to see the full demo, please visit the NEC booth. We're participating in a number of different working groups, and we could show you how these different use cases can be applied with an open networking model. Thank you, Maxime.
Thank you. Now we are going to ask Mike to give the demo.
All right, thank you. I'm going to just speak to 2 quick slides, and then instead of trying to time sync my voice with the video, I'll just play the video and let you hear the audio that was pre-recorded. It might work a little better, so I think we're going to turn the audio on for mine. Before I click the video, because one sec. Where are our slides at? Yeah, our slides. I wanted the graphic of today's. So while this is pulling up, so Glue Networks provides a WAN orchestration function. So we're a vendor-agnostic multi-vendor orchestrator, and then we build on top of the network layer. Be it, it's more. So Nick is saying it's further. I don't know how they all got into one deck here, but yeah. So go further. That's. I don't even know what deck we're on here. So. Our platform is talking directly to the network layer, in this case down to direct to brownfield Cisco routers that exist in configuring from SD-WAN. And then Cisco has a controller they call the Hub Master Controller, which handles their application policy for something which is called performance routing. So the 2 use cases I'll be speaking to are use case number 2, which is the provisioning of an application on the network, meaning telling the network what applications are on the network and what to do with them. And also use case number 1, which is application resiliency. So application resiliency is about having thresholding, and then if you're outside that threshold, to take an action. So to take an action in this case, you could switch over to your primary path, or in an example I'll show you, with a non-critical application, you could, if my internet path is down, I can just black hole the traffic because I don't want it on my MPLS network. So, so this is the video, the demo. Hello, welcome to Spring 2016. This proof of concept was created by Glue Networks to address a use case developed by the SDN Federation working group. In this proof of concept, the WAN infrastructure is using SD-WAN technology, specifically the IWAN architecture from Cisco. This is made up of two head ends providing connectivity to the primary and alternate data center and branch locations which are dual homed with both an MPLS service and a broadband internet service. This provides redundancy and increased bandwidth while lowering cost over pure MPLS VPN services. IWAN architecture leverages DMVPN tunneling for connectivity. The IWAN architecture uses performance routing, or PFRv3, for application routing policy. This is implemented via configuration on a node called the Hub Master Controller, which pushes the policy to all the branches. This demonstration will showcase the orchestration platform performing an initial provisioning of the branch nodes, then continuing to show an update of the policy on the Hub Master Controller to add a policy for Office 365 and Facebook to the existing policy on the network. Glueware Control is a cloud-based software-as-a-service orchestration platform which uses secure SSH tunnels to connect to and configure the network infrastructure nodes. Now, using Glueware Control, we will provision two nodes. We have the Seattle node and the Sacramento node, and you can see these are currently not provisioned. Glueware Control breaks down configuration into many components, and these components can be grouped together into what's known as an assembly. Here we have an assembly for IWAN, and the drop-down panel shows how an IT operations engineer can configure the given variables. Now let's move back over to the node view and take a look at the two nodes that we have defined in the system. So to provision them, we'll select both nodes, move over to the action bar, and select these nodes to be provisioned. We click Start Provisioning, and Glueware will connect and apply the initial configuration or any updates to the nodes. This will take a few minutes since it will create a backup, read, and analyze the existing configuration before making any changes. Now the provisioning is completed. We can see in the grid view it's showing provision for both of the CPE nodes. We can switch over to the log view and look at any details that transpired during the provisioning. For a manual verification, we can select a CPE and connect to it and issue CLI commands like show DMVPN to verify the tunnels are up to each of the head ends. And here we can see both tunnels are in the up state. Moving on to application control in the network, we're going to move on to configuring the performance routing. So in Glueware, we move over to the domain for PFRv3 and select a given instance that we already have configured. The current instance has a policy for video as well as voice. And you can see with voice, its preferred path is MPLS, and the backup is sending it over the internet path. Next, we're going to add a class for the application Office 365 using application mode to match the application. This is built into the Cisco feature set NBAR. We're going to select Microsoft Office as a predefined application type, which will be low latency data, since we want the best performance for the Office 365 suite. Its preferred path will be the internet to leverage the high bandwidth, and it'll fall back to MPLS if there's a problem with the network. Next, we're going to add a class called Facebook, since we don't want Facebook congesting our MPLS circuit. So here we'll select application mode again, match on Facebook traffic, again select a predefined policy, and in this case choose best effort since it's low priority data. Its preferred path will be over the internet circuit. If the internet circuit is down, it will black hole the traffic since it is not business critical. So once we save that configuration policy, the next step is to apply it to the Hub Master Controller. So here we go to the node view. Via the drop down, we select Hub Master Controller. Here we have our node, the Hub Master Controller. And again, we can move to the Actions tab to select this node and start provisioning. Now we can see the provisioning is complete on the Hub Master Controller. If we use the grid view, we can see that the features have been configured and the state is now in a provisioned state, meaning all of the feature set configured in Glueware is applied to the Hub Master Controller. For a manual verification, we can connect to the node and via CLI execute a command to look at the master policy. So here in the policy, we can see that there is an existing classes for voice and video are already there. And we can see that the new classes for Office 365 and Facebook have been applied to the node. Thank you for your time and attention today. For more information on the workgroup, please visit opennetworkingusergroup.com. For more information on Glue Networks, please visit gluenetworks.com or follow us on Twitter at Glue Networks. An entity of a WAN controller, sorry, talking to the mic here, it's being recorded. So we talk to a WAN controller for the application policy, and we talk direct to the network nodes for configuration of the nodes themselves. As we look at the future state or desired state, there will be more controller technology available, and we can talk directly to the controllers. We also can integrate via REST APIs. So let's say we wanted to build a service that terminated in the data center and connect to the NEC controller. We could have our APIs talking and provision the service end-to-end all the way into the data center. So I think as we look at future state, a lot of the hooks are there as long as you have APIs, but we're kind of trying to drive it towards open APIs on the controller side, open APIs on the orchestrator side, so you actually can orchestrate end-to-end. So you can see proof cases where this is available today, just the future state is just going to make things easier across domains.
Thank you. And I would like to apologize for these technical difficulties. I think because it's not our fault, I need to speak with Microsoft and tell them that they need a better federation between audio, video, and the slides with PowerPoint. I'm afraid you're right. Now, concerning the voting, this is where we are. So my guess is only 2 people voted. So please go on your app and start voting. Sure. So every time we launch, you need to take this, so you won't be recorded.
Great, thank you, Maxim. The first time we launched a mobile app, so we're all kind of going through a learning curve. So anyway, if you download from the App Store, it's called Compass Directory. So you can just download that, and then when you're in that, just basically you'll see the ONUG event, and then you just click on ONUG, come into this session, and then you can click and vote on which one of the top 10 requirements you prioritized. And then we'll be able to provide all of those kind of test or polling results back to the community post-ONUG, probably on Thursday or so. Also, polling for all of the sessions are open all day and all day tomorrow. So polling won't stop now. It'll continue. So, so don't fret if you don't get to it in the next 5 minutes or so. Okay?
Third person voted. And yes, so for us at ONUG, based on the results of this, we'll structure what we are going to do during the summer and the fall. And that's it. So let's go back. Yeah. So, yep, any questions? I will take this for a no. Very good, thank you.